Student Notes Parabolas. Today we're going to be talking about the critical values of the parabola and how to determine equations based on different parts that have been given. So notice in questions 1 and 2 that we are using a graph to help us find all of our critical values. Parabolas are very simple in the fact that they're very symmetrical about a line called the directrix and the other point called the focus. The vertex of the parabola is located at the origin. The focus is located 5 units down. The directrix is a horizontal line, y equals 5. Please represent the directrix every single time as a line. Do not just put the value 5. Axis of symmetry is the vertical line that passes through the vertex and the focus. That's going to be x equals 0. Please also represent the axis of symmetry as a line as well. Use your foldable to help you determine what your equation is. There are two ways to write it. It is either going to be written as x squared equals negative 4 times 5y, or it's going to be written as y equals negative 1 over 4 times 5 times x squared. And yes, that can be simplified to 20 or negative 20 in both of those cases. Your domain and range is fairly straightforward. Domain is all real numbers. Range starts at negative infinity and concludes at 0. Number 2. Vertex is located at negative 2, negative 1. Your focus is there at negative 1, negative 1. Your directrix is a vertical line this time, x equals negative 3. Your axis of symmetry is a horizontal line, y equals negative 1. The equation of this line, or this parabola, is y plus 1 squared equals 4 times 1 times x plus 2. Or it can be written as x plus 2 equals 1 over 4 times 1 times y plus 1 squared. You'll notice the only difference between the first equation and the second equation in both examples is that the value 4p has been multiplied to the other side of the equation. And when you multiply, you actually multiply by the reciprocal to move it to the other side. Your domain here begins at negative 2. Notice the directrix is not a part of the domain of the parabola. That is always the case. And your range is all real numbers. Alright, moving on to question number 3. We are now reversing the order. Given the equation, you are going to determine all of the critical values from that. Vertex is located at 2, negative 4. The value of p in this instance is 1. The focus is 2, negative 3. Let's stop for a moment and let's further explore the value of p here. Remember that 4p equals 4 is the way that I determine that it is 1. The directrix is a horizontal line, y equals negative 5. The axis of symmetry is a vertical line, x equals 2. The domain is all real numbers, and the range begins at negative 4 and concludes at infinity. Alright, let's go ahead and graph this thing so that the domain and range, additionally the axis of symmetry, makes sense. So we'll start by moving over 2, down 3, putting our dot. The value of p is 1. So the distance, let's try again, shall we? 2, negative 4, value of the vertex. Value of p tells me to move up 1 and down 1, and I'll go ahead and draw my directrix as a dotted line. Alright, the next thing I'm going to do is I'm going to find those reference points. Remember, the reference points are 2p units away. It's going to help you accurately draw your stretch or compression of your parabola. So it's going to look like that, and then I can sketch it like this. Number 4. Again, given the equation of the line, go ahead and find all the critical values. Please be prepared to share your response to question number 4 with your group mates tomorrow in class. The graph of y equals x squared is translated 2 units left and 5 units up. Write an equation to represent the new line. Okay, so the first thing I want to do is I want to represent the translation as y equals x plus 2 squared plus 5. The next thing I want to do is I want to rewrite it in standard form. So that means that the y and the 5 must be together. So I get y minus 5 equals x plus 2 squared. So right here, the value of p is 1, or the value of 4p is 1. So that means in order to write this clearly in standard form, I'm going to separate out my 4 and my p and rewrite them together. So I'm going to multiply 4 times 1/4 the value of p and put it there by the single term. If I would have written it the other way, y minus 5 equals 1 over 4p. So we're going to do 4 times 1/4 as a denominator, x plus 2 squared. Either way is acceptable. Because there's a fraction involved, I would say this way is probably more clear. Alright, question number 6 and question number 7. We are going to write an equation only from the value given in the graph. Focus at 0, 1/4. That's this guy right here. Directrix will be at negative 1/4, somewhere in here. And my vertex will be right in between at the origin. The value of the reference point is going to be at 1/2, that's 2p, here and here. And so I have my parabola look something like this here. So what that means is I'll get x squared equals 4 times the value of p, 1/4, times y. Here I'm going to go ahead and graph my focus at 4, 0, graph my directrix at x equals negative 4 here, and then I'll put my vertex directly in between at the origin. My reference points will be way up here at 8, that's 2p, and way down here at negative 8, 2p units away. Draw this sketch like so, and now I will write my equation. Y squared equals 4 times 4x. And of course you can simplify all these numbers. I just keep them separated out so that the value of 4 and p are clearly determined.